Hello everyone and welcome back to this course on implementing high availability solutions with Windows Server 2019. We are in section 5 of the course, and in this video we are going to discuss about understanding the S2D resiliency configurations. Now, before we even get to build our cluster and before I even get into the resiliency configurations themselves, I just want to show you the four machines that I've built so far, and specifically the configurations I've made so far on these four machines. Now, here in VMware Workstation, as you can see, I've already built this four machines: S2D1, S2D2, S2D3, and S2D4. Now, I just want to show you the configurations I've done on these machines if you plan on following along. So let me go to S2D1 and to the settings of S2D1. And as you can see, you just need to build them like all the other servers we've built so far, with a core image of server 2019. But for the VM settings, this is how I've done it here. So 2 gigs of memory, one processor, one SCSI disk, and this is our operating system disk. And what's special about these machines, and what is a requirement of S2D to implement storage spaces direct, is I have added 6 different disks on each machines, and these disks, as you can see here, are SATA disk. So basically, this is just a particularity of VMware Workstation, but you can also translate this into other hypervisors as well. But I'm not going to get into that here. So the process of adding this kind of disk is simple. After you build a machine, you just go to add hard disk. And now, instead of SCSI, which is the recommended way, you would need to add a SATA disk. Again, this is a particularity of VMware Workstation. Now, clicking on Next, you just go through these options. You give them whatever size you need. I made them 1 terabyte each. And then you just go ahead and add the disk. I won't do that here. I want to show you some further configurations which are critical and necessary for these disks to work in our clusters, and that is to configure the SATA disk to use the appropriate SATA channel, right? So if I go here to advanced, because this machine is turned on, I will not be able to use this drop down here, but while the machine is powered off, you will be able to. Now, as you can see, all these disks need to use a different SATA channel. So for my first disks here, SATA Advanced, you can see that it uses SATA 0 column 0. If I go to the second disk, you can see that it is configured to use SATA 0 column 2. And so on. You need to configure this for all the disks to use different channels. Now, bear in mind that this is on the 0 column channel, right? If I go next to the S2D2 and I go to settings, you can also see that it has the same configuration, 6 SATA disks attached, but if I go to the SATA channel, you can see that it's SATA 1 column 0. And if I go to SATA 2 is 1 column 1. And going further, 1 column 2. And this is the way you need to configure on all of the machines to use different SATA channels. Now, for the networking part, as you can see, I have added 2 network cards to each of these machines, one on the VM3 net and one on the VM4 net. And that is our management network, our client access network, and our storage network, because this is all we will use. Now, if you are here as well, you can also go to the options and configure the VM to version Hyper-V unsupported, and this is necessary because we will be adding the Hyper-V role to each of these machines. Now, the reason why I introduce this in the way that I do is because of how Microsoft handles the different ways in which it can do resiliency for the disks that you're adding to each machine. There are 5 different options here for what kinds of the resiliency are to be used for the disks that will be attached into an S2D enabled cluster. These are two-way mirroring, three-way mirroring, single parity, dual parity, and then mixed, which actually mixes together the use of mirroring as well as parity. Now, for this, the reason why you implement this, or the reason why the cluster implements this, is to support tolerance, or the tolerance of failures of an individual node. You can see here that the two-way mirroring and single parity can only support the loss of a single node, while the other 3 options could support the loss of 2 nodes at a time. So this is simultaneous node loss. This configuration here, or these configurations here, are also different in terms of the amount of efficiency or storage space efficiency that they provide. A two-way mirror wastes 50% of the disk because you have the mirror mirroring the data, right? A three-way mirror actually wastes 66% of the disks because you've mirrored that data twice. And then the parity options here are a little different depending on how actually the parity ends up getting configured. Microsoft does not use traditional RAID 5 or RAID 10 or RAID 6 or even RAID S, any of the RAID approaches that you're used to working with here, in order to create this parity, basically. Rather, they use a different technology they call erasure coding. That provides more or less the same or better levels of efficiency, but without wasting so much disk in the process. You can see here that thanks to erasure coding mathematics, that you can actually get some pretty good benefits here in terms of simultaneous node loss without losing so much in terms of wasted space on your disk. Now, in order to support the mathematics and also support the simultaneously node loss, we actually have to have more than your usual number of minimum fault domains for certain types of configurations you use. Obviously, to do a two-way mirror, you have to have 2 different machines, which is thus 2 different fault domains, right? We think of a machine, or we think of a machine as a fault domain in this scenario. Same thing with the three-way mirror. You have to have 3 machines in order to have 3 copies of the data. It's then when we get into the parity options here, where the number of fault domains goes up. In order to support those 2 simultaneous node failures down with the dual parity, you have to have 4 machines running at a time. And so in this environment that we're working with, that's one of the reason why you're seeing use 6 different disks and 4 different machines, so that we can see what happens when storage spaces direct sees what it has available to it, right? And then makes those configurations automatically to support the most possible flexibility in how we make the storage available to ultimately our virtual machines. Now, as I said, most of these configurations end up happening on your behalf. As we go through enabling storage spaces direct on a cluster, we'll be working with it will figure out exactly what the proper configuration should be. What you should be aware of is why Microsoft is making some of those decisions for you. The mirroring approach is there at the top. have basically a far better performance than any of the parity options that we see down there on the bottom. And so Microsoft really wants you to split your data between a performance tier that's made up of mirrored drives and a capacity tier that's made up of drives that perhaps don't waste so much data, right? You can see here that the performance tier is designed to be very fast. So if you have regularly updating data, very hot data, it tends to get pushed into that performance tier. Then as the data cools down and ends up being used less often, it can be shuttled back to the capacity tier, which is a bit slower because we have to calculate the parity constantly as we add and change that data, but it's far more storage efficient. You're going to end up with more storage that you're able to use, let's say, for that storage that exists there in that lower capacity tier. Now, this auto configuration will take a look at the hard drives that exist on each machine. And by default, use the fastest drives there for your performance tier, right? If you have drives, let's say SSD drives, it will use those for the performance tier. If you have typical traditional spinning drives, it tends to move those down to in the capacity tier. And so that process is more or less done on your behalf. Our configuration here uses all SSD drives, so it will just figure out which drives belong in which tier because effectively all the drives offer the same level of performance. But this gives you a feel for why you might end up with a configuration that you see when you start implementing this into a production environment. And in fact, if you're interested more in the specifics about how this data gets broken apart and then separated out onto the different machines and also tiered out onto the different machines we're talking about here, I will include a link to a knowledge base article that Microsoft has and talks about the fault tolerance and also talks about storage efficiency here in Storage Spaces Direct. So I will see you guys in the next video where we are going to implement a hyper-converged S2D cluster. I hope this has been informative for you and thank you for watching.